Oh my God. In the beginning of 2023, I acquired a PDP 1173. It had a serious problem though. There was a CPU cache error on boot. It quickly became apparent that there was no way to get this machine running without a replacement CPU board. I reached out to some of my buddies on the internet, and one of them had a spare board they'd be willing to sell me. The board arrived and I got to work bringing my machine back to life. There's our new board. These boards are identical. And we'll see if we can get it to work. Okay, here we go. This is really the moment of truth. In the previous videos, we saw that the CPU board we were using was throwing CPU cache errors at this point. On this boot, there are no cache errors. This board is booting cleanly. The next question is, will it find a boot device? I wasn't particularly hopeful that it would, but it would be nice if it showed something. In the end, it was unable to find a default device to boot from, but that's fine. I did notice there was an RQDX3 controller error happening, so I decided to pull that card to take a look at it. It's possible it wasn't cabled correctly. That's the RQDX3 right there. So let's pop that out. And the cable doesn't feel loose. Let's take a look at it. That's the controller. What I'm checking for is to find out where pin 0 is on this, because if this cable is in backwards, which it can go in backwards just fine. I didn't see anything wrong with the controller, but that didn't mean much. The 11 just could not have had anything to boot from. The RD52 drive that I have could easily be bad. I decided the next step was to try and use one of my Floppy emulators to simulate an RX33 floppy boot disk. These Floppy emulators are made by a company called GoTech. You can pretty much get them anywhere on the internet. There's also open source firmware that you can install that makes them much more powerful. I've modified mine to include a small LCD display, so it's easy to pick the image I want to have it represent. It had been a while since I used this particular drive, so it took a little bit of fiddling and reassembly to get it ready for use. In order to get the floppy drive working here, we're going to need to cable in on the breakout panel here. That guy right there. Removable disk 1 and 2, which is deck speak for a floppy drive. We have a bit of a problem. We use a small floppy power connector. Here's my DC power. I thought I had the proper adapter for here to use this, but turns out both of those are female. So what to do about our bad connectors here? Obviously I can't use this guy. So it's time for awesome. Here we go. In theory, this is my cable connectors, and lo, look at that. That's what we need. Really what these are designed to do is to go in line between two devices, and then you break out that connector. But in this case, we will simply patch into the back plane here. So Wow. Take a look at this. That looks dreadful. I don't know what got into that. I don't think I want to know what got into that, but we will not be using that connector. So we'll use this one instead. Put that into that. Good. We will patch this onto floppy drive, like so. Next thing we need is our floppy cable. There is something of an advantage here that I can use your standard floppy cable for this connection. This is pinned, so we can use that to line up the connector, like so. That goes in there. The red wire always denotes pin 0. So if you look here, it actually says pin 2 right there. So we know that this goes like this. And that should be it. That should be all we need to make this work. Before I moved on, I wanted to address something that's been irritating me. This machine's been set at 1200 baud since we started. And while that's cute and retro, it's really irritating to work with. So I decided to change it up to 9600 baud to get some faster response while using the console. Let's go to a nice comfy 9600 here. All right, we should be connected. Let's power up and see what we can see. I've managed to connect with the retro computing community a bit, and these are disk images to be used on RX33 drives, which are the floppy that the 11 uses, which is right there. So including XXDP, which is DEX utility package for diagnostics. So what I'm going to do is copy all the images to my thumb drive here. There's my file system table. It's a fat file system. And that is the file system that my GoTech drive will use. So let's copy these images over. Download, start out image, copy them to the floppy, to the USB drive. There they all are. Great. I plugged the USB drive into the GoTech and powered things up. With the floppy emulator in place, it should be just a matter of telling the 11 to boot the image. But no matter what I did, it would not boot. It would just get several tracks into the read and then just fail. I tried everything. I spent hours on the VCF forums talking with people much smarter than me about this, and even they said it should work. But it didn't. I was stuck again. But maybe there's another way. In 1979, DEC created the DEC Tape 2, a small cassette-based tape storage system that was inexpensive, but more importantly, communicated with the host over a simple serial RS-232 link. Some geniuses on the internet said, hey, that sounds like a great idea. Why don't we create a TU-58 emulator that can run on any Linux box, and we'll pretend it's a drive. That way we can load data over a serial connection directly into the PDP-11. Sounds great. In order to make this work, I needed another serial port. Fortunately, my machine has a DLV11J, which is a 4-port serial controller. All I needed to do was configure the board to match the configuration for the emulator. Sounds simple, right? Looking at the documentation, these 4 pins, E, D, S, and P, on the 1 means it is even parity, which is pretty standard. The second one is the data length, It's set to 1 also, which means it's 8 data bits, also pretty standard. The third one is how many stop bits there are. Wired to 0 means it has 1 stop bit, also pretty standard. But check this out. This bottom one is wired from pin X to pin 0, which means parity is enabled. Since the parity is enabled, the communication is 8E1. I was using 8N1. Using some extra wire and my wire wrap tools and a pair of pliers, I moved the jumpers around to reset the port to what I was expecting. I reinstalled the DLV11J into the machine and using another USB to serial adapter, connected it up to the laptop. After starting up the 11, I started the TU58 file system emulator program and tried to connect to it from the PDP-11. After sending it a boot command, I could see activity on the emulator, but it would not boot the image. I tried starting the emulation in debug mode so it would show each command as it was received by the emulator, and I could see a boot command showing up. It was trying to boot, but it just wasn't succeeding. At this point, I was pretty disheartened. It had been almost 2 months of no progress, with a lot of late nights and a lot of frustration. It was time to call in a professional. I reached out to Mitch Miller of Keyways Inc. and asked if he'd help out. Mitch is a great guy and has an incredible amount of experience with older DEC hardware. After some emails back and forth, he agreed to take a look at my machine and see if something was wrong. So I stripped down the chassis, packed up the boards, and shipped them off to Ohio. A week or 2 later, I got an email with screenshots. My 11 had booted. This was both a relief and a frustration. It showed the hardware was fine, but what was I doing wrong? Mitch agreed to keep digging, and a few weeks later told me there was definitely something squirrely with the Gotek floppy drive. It was corrupting images. He could not get it working. Mitch agreed to sell me a SCSI controller card so I could match his environment back home, and he packed up all the hardware and sent it back to me. Here we are, 8 months later, and 4 months after we got the equipment back. Great box. Let's go through this stuff first. This is the most important guy. This is my fully functional 1173 mainboard. That's back. That's now been tested and we know it works correctly. Memory card is back. Fantastic. There's our floppy controller. This guy is our RQDX3. So that's our disk controller. And this is where it gets interesting. This is new. This is an Emulex SCSI controller. SCSI drives were after the 11 was originally built, but they were relatively new and they're starting being used for workstations and whatnot. This one's built by Emulex, who made tons and tons of these boards. This is going to be it. This is what's going to get us going. So that Emulex board first comes with a SCSI cable. It's a big 50-pin connector. But all of this is wonderful. But having a SCSI cable and a SCSI controller like this is all going to be fine and dandy, but won't work unless I have a SCSI device to boot from. What I chose to do was to go with these guys. Rabbit Hole Computing. Let's take a look at it. Actually, I haven't looked at this yet. I know I've read about it online, but I've never actually seen it in person. All right, let's see what we have here. And what we have here, it says Zulu SCSI RP2040 SCSI ribbon cables, no cable. Basically, you can take a SCSI card, an SD card, present it via the SCSI bus to the machine as a bootable image, or basically a disk drive. So all I need is an SD card that has a bootable image for this machine, and we should be able to boot. This arrangement was tested in Ohio with a slightly different card. So, fingers crossed, this is the configuration we're going to work with. All I need to do now, get this machine put back together again. Let's get started. We're at the milestone now. As far as I know, everything is reassembled correctly. I have to be clear here. This machine has not been powered up in 6 months. The boards have gone on an epic journey all over the United States. And of course, my worry is I hope I put everything back together correctly. I actually had to go back and look at one of my old videos to make sure. Let's connect up to the terminal session, which we just did. Power on. Dropped right into the monitor. Now, why did it do that? There we go. All right, we're going to let it go through its full tests. Passed all the tests. Awesome. Okay, let's see what we've got here. If we have anything new, we do have a DL boot device, Arlo 1 and Arlo 2. If I remember correctly, I don't remember if those were on the previous boot, but that should be this SCSI connection right here. So far, so good. No errors, no issues on the boot. All right, next step is I need to hook up the new SCSI controller, which is this guy right here. And I need to get a boot image on it, which I have. So I'll be back in a few minutes. I carry around this pouch that contains a bunch of SD cards, micro SD cards, and USB drives. It comes in handy when I need something quickly. I shuffled through what I had lying around and picked out one of the small 4 gig micro SD cards, put it into an adapter, and it was ready to go. I socketed the SD card into the laptop, formatted it up as a FAT file system, and made sure it presented it as a proper volume. Now all I needed was a boot image. The next thing we need to do is we need to copy disk images onto this and get it to boot. For that, and it just so happens, over here on my display shelf, I have this wonderful machine. This is a PDP 11 emulator. It's running basically emulation software that pretends it's a PDP 1170. On the back end, it's actually a Raspberry Pi 4, but fortunately, on the file system that's on it, it has bootable disk images. So we're going to steal them. With the SD card mounted on the laptop, all I needed to do was copy the image from the PDP 11 Raspberry Pi over to the local file system. I used SCP and copied it onto the local SD card. We're going to call it hd0.img. Now, this file name is very specific because it is what the SCSI controller that we're using denotes the very first hard disk image that's going to be served up by the SCSI controller. We'll copy that over. That should be our bootable disk. That's our SD slot. Go ahead and put that guy in there. Clicked in very nicely. This is our SCSI cable coming out from our MLX controller. So we're going to go ahead and note this has a keyed connector, so we have to make sure it gets plugged in correctly. We're going to go ahead and do that. which device it's going to try to boot from. In theory, it pretends it's an RLO2. Let's try it. RLO2. I just made a very silly error. The log is correct. The device names are wrong. So let's try a different device name on this. I don't know what I was thinking the first time through. So we know that the SCSI controller has mounted the first disk image via the firmware on the Zulu SCSI controller adapter board. That's good. So in theory, the Emulex controller should see that as the first disk. So what I need to do is tell this to try booting the first disk, which should be DU0. Unfortunately, this didn't work. I began to wonder if the problem was that I had a RQDX3 disk controller in alongside the Emulex controller. So I decided to pull the RQDX3 out and put the Emulex controller in the proper slot. But a Q bus is divided in half, and it's ordered 1, 2, 3, 4, 5, 6. So since this card is going into the third row, the Emulex card, it needs to move over. So let's pop that out. Like that. And we're going to put this fellow. I'm kind of curious what the model number is on this. UC07. Okay, UC07 is, I'm seeing several folks on the internet who are using this card. So this is good. This is not an unusual card by any stretch. So that's it now in slot. There we go. Slot. Oh, that's new. That shows no errors. Showing a green light. I'm not getting any response from the console anymore. I knew I was really close. I decided to try one more thing and switched the boot image over from an RT11 boot image to an RSX11 boot image. Oh my God. Oh my God, it's working. It's hard to explain what I was feeling at this moment. When I started the PDP 1173 restoration project, I expected it to be relatively easy to get the machine running. What started as a curiosity has turned into an almost 10-month long project. But seeing RSX11M Plus booting up on my hardware, on my workbench, on the physical machine, it was quite a moment. The entire boot up sequence took about 2, maybe 2.5 minutes to complete. During this time, the controller was flashing away happily, telling me that data was being read off of the SCSI card and behaving in a normal fashion. I'm not sure if this would be faster with a localized drive or not. Maybe that's something for a future video. But for now, I was just absolutely stunned and excited to see this machine up and running in the way I had always hoped it to be. What we're booting here is RSX11M Plus. This was one of the large-scale operating systems that DEC put out on the PDP-11 starting at around 1979. It was in development for many years, and then it passed on to various and sundry other owners as the company that was formerly known as DEC slowly fell apart and was acquired by several other companies. It quickly became apparent that I have no deep knowledge of RSX11. My experience with it with the DEC Pro systems back in the 80s was a lot of fun, but that was a long time ago, and boy, have I forgotten a lot. So for now, I was content to muck around in the help systems and play around on the command line, but I'm going to need to spend much more time relearning the operating system. For now, I was just ecstatic that things were up and running and I had a working machine. Well, now that it's up and running, how do I stop it? The internet says this is the proper shutdown process. Let's see. Although it does say it's safe to turn it all off regularly, so let's see what happens here. 0. I'm tired. Yes. Stuff didn't mount. Really curious what happened to the second volume. I'll have to figure that out next. I do. Ooh. I have all the activity logging turned on. The SCSI controller has the debug switch turned on, which means we probably have an incredibly large debugging log, which isn't really going to help very much. Inserting nuclear control rods into the reactor for immediate shutdown. DU0, dismount complete. There she goes. Drop to the monitor. Say goodnight, Gracie. Thanks for watching. If you like this video and would like to see more, please click the like and subscribe button down below or leave a comment. We'd love to hear from you.